Hello guys, trust you're doing fantastic. In today's video we're going to be talking about binary division. So we're going to be carrying out division operation in binary number system. Now the example says divide 100110 base 2 by 100 base 2. Now this is how we're going to solve this exercise. Now all we need to do is to write this division sign. Then we have 1001110 divided by 100. Now from all indication we can tell that this binary value is larger than the divisor. So let's begin the process. The rule says when you want to divide a situation like this, or you want to carry out such operation like this, all you need to do is first we consider the single bit. When you consider the single bit and then you compare it with the divisor, if it is less than the divisor, it means division is not possible. So you need to consider 2 bits. So the next bit. Now if we consider the next bit, it means that what we have here is going to be 1 and 2. It means we're going to have 1 is going to be absent at this point, 2 is going to be present. So it means what we have here is going to be 2, and what we have as a divisor is 4, which is 100. Considering 3 bits, it means the decimal equivalent is going to be 4. So it means it's still less than the divisor. So the next thing we need to do, we need to extend by considering 3 bits. So we'll consider this 3 bits. If you notice, I indicated it with a little purple dash mark. Alright, so considering this 3, we have 3 bits, and the decimal equivalent of this 3 bits is 4, which is equal to what we have as a divisor. So in that case, division is possible. So all we need to do is to say 100 into 100. How many times can we have this into this? It means we can have that one time. Okay, so 100 into 100 is 1, so we have 1 written up there. We say 1 multiplied by 100, it's going to give us 100. Now we need to carry out subtraction. So we say 0 minus 0, we're going to have 0. 0 minus 0, we're going to have 0. 1 minus 1, we're going to have 0. Right, so the next thing we need to do is we need to bring down this 1 to this part. We have 1. So we say 100, rather than saying 100, we say 100 in 1. It's not possible because converting this into decimal, this is just 1 and this is 4. So this is lower than the divisor, so it's not possible. So in this case, what do we need to do? We need to bring down the other one. But before you do that, you can only, in binary division, you can only bring down this value once, only after you've introduced a 0. It means you can do it one at a time, not just immediately, or you bring them together. It's not possible. So once we notice that 1 cannot divide, 1 cannot go into 100, cannot go into 1, what we need to do, for we to bring down this other one, we need to add 0. So we need to write 0. So this is how we got the 0. Now if you're looking at 100 in 11, this one means that once you have 2 bits, you have 1 and 2, which is 3. It's still less than what you have here, which is 4. So in that case, it means that we need to bring down the other one. But before we do that, we need to introduce 0 first. So that's why we have the second 0, and then we bring down the third one. Okay, we'll bring it down, the third one at this point. So we have 111. So in this case, since we have 111, the equivalent in decimal is going to be 7, which is larger than 100. So in that case, how many times would 100 go into 111? Of course, what you're doing is like you're saying that how many times will 4 go into 7? It's just going to be 1. Okay, so we say 1. We write 1 up here. We say 1 multiplied by 100. We have 100. Now we need to carry out this subtraction. We say 1 minus 0 is going to give us 1. 1 minus 0 is going to give us 1. 1 minus 1 is going to give us 0. Okay, so the next thing we need to do is we need to bring down this 0, the last 0 we have. We need to bring it down, and this is the 0. Now if you look at these 3 bits, now this 0 before 1 is actually not significant. Okay, we can as well ignore it, not to even write it. It's not significant, so we consider 110, these 3 bits. So once you have 110, it means you have 4 and 2 present, considering 3 bits. So it means you have 4 and 2, which is 6. 6 is larger than 4, which is 100. So how many times can 100 go into 110? Which is nothing like saying how many times can 4 go in 6? Is 1. So we write down the 1 up here, and then we say 1 multiplied by 100. We have 100. Now let's carry out the subtraction. We say 0. Now once you're carrying out the subtraction, don't forget the rules. Okay, the rule says when you have 0 minus 0, we're going to get 0. So that's how we got 0. Now for subtraction rule, it says 1 minus 0, you're going to get 1. That's how we got this 1. Subtraction rule says 1 minus 1, you're going to get 0. That's the rule of subtraction. Now you have the last 0, so you can easily just directly bring it down. So you have 0, 0, 1, 0. Now we cannot stop this division process because we have not converged, we have not arrived at 0, 0. So in this case, what we need to do, since we have 0, 0, 1, 0, we need to introduce this 0, this last 0. Now for we to introduce this last 0, all we need to do is that we need to introduce points first. So that is why we have introduced point. So once we introduce this point, then we're allowed to introduce this final 0. Now in that case, we now have 1, 0, 0. Now how many times can 1, 0, 0 go into 1, 0, 0? It's going to be 1. So that's why we got this 1. So we say 1 multiplied by 1, 0, 0, we're going to get 1, 0, 0. Now if you do the subtraction, we're going to get 0 minus 0, 0, 0 minus 0, 0, 1 minus 1, 0. So at this point where we have everything at 0, it means we should stop the division process. So it means our final answer is 1, 0, 0, 1, 1.1. Right, so this is how easy it is. Now the next thing we need to do is let's check if what we have done is correct. All right, so let's check. All right, so the final answer gives us how many bits? We have 1, 2, 3, 4, 5. Right, we have up to 5 bits, right? And then we have the dot and 1. All right, so it means at this point we're going to be looking at 1, 2, 3, 4, 5, 6, 7. So let's consider a 7-bit where we have 2 raised to the power 6 as the highest, and then down to 2 raised to the power 0. Then the equivalent of that is going to be 64, 32, 16, 8, 4, 2, 1. All right. So let's compare what we have here. 1, 2, 3, 4, 5, 6, 7. So this is the maximum number of bits that we have here, 7. So it's equivalent to what we have here, 1, 2, 3, 4, 5, 6, 7. So it means what is going to be the equivalent of this binary in decimal. This binary in decimal is what we use in our division process. All right, so what we're looking at is this binary, the equivalent in decimal. So we'll get the equivalent in decimal, and we'll also get the equivalent of this binary in decimal. All right, so let's go. Since we know that 1, 2, 3, 4, 5, 6, 7, the numbers of bits here is 7. So it means when we're using the direct method, our highest number is going to be 2 raised to the power 6. All right, so let's go. So 1001110 is equivalent to 74, and then 100 is equivalent to 4. Now we have to carry out the division of these numbers. It's going to be 78 divided by 4. That is going to give us 19.5. Now let's convert 19.5 to decimal. Now you have 19.5 using the direct method. So it means what we're going to have is for 19, the highest number we're going to have for 19 is going to be 2 raised to the power 4. So we're going to have 2 raised to the power 4 at this point, because whatever raised to the power you have should not be more than the value 19. So we're going to stop at 2 raised to the power 4. So we won't have 2 raised to the power 4, 16 will be present, 8 and 4 will be absent, 2 will be present, and 1 will be present. Now if you sum that up, you're going to get 19. 16 plus 2 plus 1 is going to give us 19. Then you have a decimal point. Now the place value for this value after the decimal point is going to be minus 1. So this is where we got minus 1. So for we to add up this value so that we can arrive at the decimal value, we say 19 plus 1 times 2 raised to the power minus 1, because of this place value minus 1. So if you do that, you're going to get 19 plus 0.5. We say 1 times 1 divided by 2, right? So this is going to give us 0.5, right? So in that case, if you sum everything up, you're going to get 19.5. So it tells that what we have, this value 19.5, is equivalent to what we have as 10011.5, what we arrive or what we achieve or got initially. All right, so this is how easy it is. So we've been able to prove that our final answer is correct. So at this point, I'm going to encourage you to pay attention to the subsequent videos in this channel. All right then, enjoy this video. Bye.